All right, let's do the law of sines. Let's use it to solve some problems. So, example 2. Solve the triangle to the nearest tenth. We're going to be rounding pretty liberally here. Okay, so first part is going to be part A. That's going to be the triangle alpha, beta, gamma. And alpha is 50 degrees. Gamma is 30 degrees. We don't know B. We don't know C. And A is 10 units. Again, A is opposite alpha, B is opposite beta, C is opposite gamma. Alpha, beta, gamma, A, B, C. All right, so we have to solve this triangle. So we're going to use the law of sines here. And there are 3 ratios, and we want to pick 2 ratios. Okay, we're going to pick 2 ratios. And the first ratio that we pick is a known side and opposite angle. And then the second pair that we pick is going to be one unknown. So what do I mean by this? So, like, we have 3 ratios. Sine alpha divided by A is one ratio. Sine beta divided by B is another ratio. We just need to pick one pair that we know both. Alpha and A. We know both of these. So that's where we're going to start. The sine of 50 degrees divided by 10. And remember, there's no cancellation here. The sine of 50 degrees is its own thing. So the second thing is to pick a pair that we don't know. So C and gamma would work, because there's one unknown between C and gamma. Beta and B does not work for a pair, because that's 2 unknowns. That's too many. We chose beta and B here, we wouldn't be able to solve at all. We have to choose gamma and C. Sine of gamma, which is 30 degrees, divided by C. Solve this for C. It's a good idea not to round until the very end, otherwise you get compounding rounding errors. So we can cross multiply, solve this however you want. Well, not however you want. Make sure to solve it correctly. You can get something like this. And sine of 30 degrees, we know exactly. It's exactly 1/2. But usually it's a good practice to just get to the end. And again, type it into your calculator at the very end. Okay? So round to the nearest tenth at once. So part C is going to be, we'll use Google again. 10 sine of 30 degrees divided by the sine of 50 degrees. Make sure your calculator is in degrees. About 6.5270. And I know it said round to the nearest tenth, so we're going to say 6.5. C is approximately 6.5. But we're going to have to use... Actually, we're not going to have to use C for anything. But yeah, we could have rounded better. All right, so how do we use the law of sines to find either one of these last ones? This is 2 unknowns. We can't use the law of sines here. Well, it's much easier than that. If this is 50 and this is 30, everything has to add up to 180 degrees. It's a triangle. All right. So this is just going to be 100 degrees right here. That's beta. Beta is 100 degrees. Now we can use the law of sines again. You could choose gamma and C, but it's usually a good idea to use the same pair that we used at the start, because these are going to be exact answers. And now sine of beta over b. Follow the exact same steps. And you're going to get that b is 10 times the sine of 100 degrees divided by the sine of 50 degrees, just like before. Type that into a calculator. The only thing that changes is the 100 degrees. About 12.8558. But again, we can just round that to 12.9 because that's what it wanted us to do. All right, so we have C, we have B, we have beta. We solved the triangle. We found all the sides and all the angles. We boxed our answers. You can box your answers like this. You could have boxed them down here instead. As long as I can clearly see your work and clearly see your answers and that you're writing things mathematically correct, I'm not going to be picky with how you express it here. Okay, that's how we do it. Let's do one more problem. And the next video is when things get really fun. We're still on the basics right now. The basics law of sine. Some wacky stuff can happen with law of sines. Let's look at a triangle called ABC. Not like that though. ABC. It's not a right triangle. It's almost right, but a little wrong. Like so. This is going to be 43 degrees down here. We're going to do the exact same thing. Okay, just some more practice. It would be a good idea to pause the video, see if you can get it on your own, and then I'll explain it. So pause me now. All right, so again, all the angles have to add up to 180. That's probably the easiest place to start in this case, or you can just start with law of sines. So B is going to be 180 degrees, minus 98 degrees, minus 43 degrees. I don't know if I can do that in my head. That's 141. Is it 39? Maybe. I think so. Oh, real quick. One thing that's a good idea. Law of sines says that the side lengths are proportional to the angles. So when you finish your answer here, you should check. 100, that's the biggest angle. This should be the biggest side. And it is. All right. It's 30, that's the smallest angle. This should be the smallest side. And it is. They're proportionate to the sine of the angles. All right, this one we found B. Now we set up law of sines, pick an angle and a side that we know. Angle, opposite side, good. That's how we start. Sine of 39 degrees divided by 22. Now pick a angle and opposite side that we don't know. You could choose 98 and A. You could choose 43 and C. It doesn't matter. Sine of 98 degrees over A. And again, just solve these the same way that we've solved it before. And you're going to get that A is 22 times the sine of 98 degrees divided by the sine of 39 degrees. Or you're going to get that A is approximately equal to, use a calculator, 22 times the sine of 98 degrees, don't forget degrees, divided by the sine of 39 degrees. A is about 34.6. And do the same thing with B, or with C. Again, the sine of 39 degrees divided by 22 equals now the sine. Now we're looking at C, so we're looking at this pair. 43 degrees and C. And again, you follow the same exact steps. You're going to get that C is equal to 22 sine of 43 degrees now. Again, divided by the sine of 39 degrees. So it's a 43 in the numerator now. But it's almost the same. 23.8. And again, another way of expressing your answer would be to say that beta is 39 degrees. A is this, B is that, and C is that. Another way of expressing your answer. And again, let's do that gut check. Smallest angle, is this the smallest side? Oh, let's write down what C is. 23.8. Smallest angle? Yep, smallest side. Biggest angle? Biggest side. Good. Those ratios should work like that. All right, and that's this video. These are, by the way, what are known as angle-side-side triangles. Sorry, angle-angle-side triangles. Which means that we start by knowing, hold on, what did we start with on this one? Wait, no, this is an angle-side angle. Right, these are the ones that we started with. Angle-side angle is what this triangle is. Because we start with an angle, the side between them, and another angle. This is actually an AA or ASA triangle. All right. And I think the one before this was AAS. Angle, then another angle, and then the side on the other side of that was AAS on this one. I don't make a big deal about these, but the next one, the next video is going to talk about side-side angle, SSA triangles, and that's where things get really, really fun. All right, good luck. Let me know if you have questions.